All right, let's talk about building a smarter AI. I mean, one that actually thinks before it speaks. Today, we're going to break down a really cool project that uses something called an Agentic RAG pipeline. It's all about getting past those clunky, generic answers and moving into responses that feel, well, truly intelligent. Have you ever felt like your AI assistant just isn't that bright? You know what I'm talking about, right? You ask it a question, and what you get back is this clumsy, kind of irrelevant answer. It feels like it just ran off, grabbed the first thing it could find, and didn't think about it at all. It's a super common frustration. And guess what? That's exactly the problem we're going to tackle today.
So why does that happen? Well, a lot of the time, it comes down to a standard process called RAG. That's Retrieval-Augmented Generation. The best way to think about it is like having a research assistant who, for every single question you ask, no matter how simple, immediately sprints to the library. They grab a huge pile of books, run back, and just start reading them out loud to you. They never stop to think, hey, do I already know this? Or, wait, are these even the right books?
And this really shows you the difference in a nutshell. On the left, you've got your standard RAG. It's got one mode, always go get information, no questions asked. But the agentic RAG on the right, it's way smarter. It adds one absolutely crucial step right at the beginning. It thinks. It actually stops to decide, do I even need to go to the library for this? And if it does, it figures out exactly what it's looking for. Which, of course, brings us to the hero of our story today, this smart agent. This is the core of the whole agentic RAG pipeline. It's not just blindly fetching stuff anymore. It's a real decision maker. It's like swapping out our hyperactive book-grabbing assistant for an experienced researcher who knows how to work smarter, not just harder.
So what exactly is an agentic RAG pipeline? Let's get a clear definition. Put simply, it's an AI system where this agent gets to autonomously decide the best way to find the information for your question. It's not just running down a checklist or following a rigid script. Nope. It's making judgment calls, on the fly. Okay, so what makes this agent so smart? It really comes down to three critical decisions it makes. First, it asks itself, do I even need to go searching for this, or do I already know the answer from memory? That's huge. Second, if it does decide to search, it thinks about the best way to ask. It can actually rephrase your question to get better results. And third, and this is so important, it knows when to stop. It decides when it has gathered enough good information to give you a confident and accurate answer.
All right, I know what you're thinking. Building something this smart, it's got to use super expensive, really complicated tools, right? Well, you'd be surprised. The answer is no. And honestly, that might be the most powerful part of this whole idea. So let's take a look at the all-star tech stack that pulls this off, because it is way more accessible than you might think. And here's the best part, the real kicker. It's all built with free open source tools, every single component. This is what takes a cutting-edge idea from just, a theory on a whiteboard and turns it into a practical blueprint that literally anyone can build. It's just a perfect example of how open and accessible, powerful AI development is becoming.
So let's meet the all-star team. First up, for the brain, the LLM, it's using Groq with LLaMA 3. That means it gets incredibly fast and free inference, which is just the fancy word for generating the answers. For its memory, the vector store, it uses ChromaDB. And what's cool about that is it runs right on your own machine. Your data stays private and you have zero server costs. Then tying the whole thing together, you've got LangChain, which is pretty much the go-to framework for building these kinds of smart agent systems.
Okay, so we've got the smarts and we've got the tools, but this project is way more than just a clever script. It actually uses professional software engineering practices. We're talking serious automation and quality control to make sure the whole system is solid and reliable. This is really the step that takes you from a cool little hobby project to a real production-ready system.
And this quote right here, it's absolutely crucial. What it means is that every single time a developer pushes an update to the code, a whole automated process just kicks off. It does linting, which is basically an automatic check to keep the code clean. It runs a bunch of tests to make sure nothing broke. And here's the most important part. It runs an evaluation gate to make sure the AI's answers haven't actually gotten worse with the new code.
You can see that whole process in action right here. A developer pushes some new code to Git. Instantly, an automated system using GitHub Actions wakes up. It checks the code quality, runs the tests, and then, the big one, it evaluates the AI's performance. Now, if that performance drops even a little bit, the whole process is blocked. That bad code cannot be merged. It's like having a powerful, automated quality control guard for your AI.
So by walking through this whole project, you've actually just gotten a crash course in several core concepts from a field we call LLMOps. And it's really just all about bringing that professional discipline and reliability to the wild world of building apps with large language models.
Okay, let's tie this all together. We've seen how the agent makes its smart decisions, we've seen the automated quality checks in GitHub, and we've seen this focus on observability. See how all these pieces fit together? It creates a truly professional workflow. And the big takeaway here isn't just about writing clever code. It's about building a reliable, repeatable process you can trust.
I want to zero in on this idea of observability for a second because it is a total game changer. With a tool called LangSmith, every single step the agent takes is logged. I mean, every thought it has, every search it performs, everything. You get this perfect, crystal clear trace of its entire reasoning process. For a developer, this is basically like having a flight recorder for your AI. You can see exactly why it did what it did, which makes it so much easier to debug and improve.
So, there you have it. We've seen how to build an AI that genuinely thinks before it speaks, and how to do it with free tools and professional-grade practices. This stuff isn't just a theory anymore. It's here, and it's accessible to everyone, which really just leaves one final big question for you. Now that you have an idea of how it's done, what problem are you going to solve with it?